sequestration of growing the fibers, we're also able to make our composites lighter in weight. So if we reduce the weight of our cars, we can improve our fuel economy as well. So we get benefit from sustainability in more than one way. So for example, these are types of applications that already make use of natural fiber that you can find in your vehicles. This is a seat back in a third row, so it just gives additional support to that construction. And then applications such as this, which is an armrest substrate that goes in your door. So these types of things are light in weight compared to plastic materials, so we're able to reduce our vehicle weights, but they're not that attractive. And so these tend to be things that are hidden and covered by foam and
what are these made out of?
Things like that.
This is
so
wheat?
These particular ones are made out of knaf fiber. So this is just a fibrous plant. It's not a food crop or anything. And it can be grown in most parts of the world as well.
Are these in use? Or these hypothetical?
These are in use. So the components here are in use.
In, all the cars currently being made, or?
It depends, because the design of all of our vehicles are slightly different,
Right.
depending on what supplier makes it and what the requirements are for that particular vehicle. So this one that's being passed around is in our new Escape. And this one is not in production anymore because it was in our Taurus X, which we don't make anymore. But a similar thing is used in the Flex, which has a verb. But right now, currently under development, is looking at injection molded applications. So Angela kind of touched on injection molding, which is a process by which a lot of our plastic and composite materials are made. It allows us we melt down the plastic, and we can combine it with the natural fibers instead of fiberglass. And it allows us to make much more complex shapes and combine a lot of different functions into one piece. So the challenge for the natural fibers is, because we have to melt the plastic down, we have to make sure that we don't get too high in temperature that the fibers start to degrade and discolor and start to smell. So we worked on this for quite a number of years, and in 2009 we had our first application in the Ford Flex, the 2010 model year, in the storage bin. So there's 2 of these small bins in each Flex vehicle, and just for that one vehicle line in this small part, it reduces our petroleum usage by 20,000 pounds every year and our CO2 emissions by 30,000 pounds every year, which is relatively small compared to what Angela was saying about the soy foam. But now we can start to migrate it to other applications as well. So if you look at things like this, which have higher requirements and uses a much more bulk of the material, we can start to get much more impact for reducing our CO2 emissions. In the start, we were making these materials look exactly the same as our non-sustainable materials by coloring it black. But this is what it looks like in its natural form, and so you can see some of the fibers. And we're starting to investigate whether we should draw out that there's fiber in it so that our customers know that we're using a more sustainable material. And so if you take a look here, we've added some color and different effects to try to bring that out to see if that's acceptable for the design here. In addition, the wheat straw is a waste fiber. After the grain is harvested, the wheat is primarily burned. Some of it's used for compost, but because we get it from Canada, the growing season is so short that it can't compost in time, and so they end up burning a lot of it. So we're putting some more value into it and taking away from burning, which releases a lot of bad stuff into the air. And we're looking at other kinds of waste products as well, like coconut shown here. The husk fiber is a waste product after the coconut is harvested. And we're partnering with Scott's Miracle-Gro company, the lawn care company, which may seem like an odd match, but they already take the waste product from the coconut harvest and use it in a lot of their lawn care products. And then they have some leftovers, so we're using their waste stream from their lawn care products and taking that fiber and combining it with plastics to see if we can make additional use out of it in our vehicles. So right now we're concentrating on using petroleum-based plastics, but eventually combining with the research that Angela talked about of the bio-based plastics, we'd like to combine all of them to make a totally renewable material. So, for example, let me draw your attention to the BioDoor display right over here. This shows how many different types of materials we actually use in a vehicle. There's a lot of different types of plastics. They have different requirements. Some of them need to be stiffer, some are soft, some are flexible. So there's a place for every type of material that we're trying to investigate and replace with a renewable material. So these are all demonstration kind of prototype parts, but it gives you an idea of how much potential there is in these bio-based materials in reducing our carbon footprint in a vehicle. So this is just a door, and just the door itself has 10 to 15 different types of materials themselves. So if you want to take a closer look later on, these plaques tell you what material we've used in the prototype part, what it replaces, and then an example of the renewable content that's in it. And if you just take a look at the variety of different types of materials, the different textures, the different feels, and you can even take a look here. This is the wheat straw material. We've made part of it where we've kept the fiber visible, so you can see that it's a renewable resource. And then the other half we've painted to show that you can also make it look like just any old plastic as well. And then we've extended the idea as well over by Angela. She'll talk about that component over there.
So this is the seat that we had fabricated that has soy foam, seat back, seat cushion, and headrest. And it also demonstrates the use of the polylactide corn-based fabric as well. So we were able to have it upholstered with that. And it also has a natural fiber seat back, as well as a sugarcane polypropylene side shield. So when you combine all these material technologies together, you're able to reduce the CO2 by around 125 kilograms per vehicle if you were to replace traditional materials with these bio-based materials.
So I have a question in terms of implementing some of these designs, and is there any future program, or is there a scale problem, or
It's just a time issue. I mean, it's just like, soy foam took, 6-7 years to develop the right formulation to pass all the requirements. So the other ones are at various stages in the R&D process. So some might be, a year away, or some might be 5 years away. So they're just different times to complete all the testing. And a lot of people don't realize how hard it is to get materials approved through the system, because there's like all the durability testing, and it's just an issue of, and then sometimes you have to go back and reformulate and then test again. So you just have to go through the process, and we don't want to be, too quick to implement something that isn't ready, and then have an issue, and then people will be, oh no, we don't want to use biomaterials. We have to be very sensitive to our engineering community and to our customers.